Edexcel Decision 1, Linear Programming 3, using the simplex method. Setting up a simplex tableau. So we're going to look at the same two-dimensional linear programming problem we've looked at before with decision variables x and y and the three constraints as seen below. X plus y is less than or equal to 12, 2x plus 3y is less than or equal to 30, and 2x plus y is less than or equal to 20. And not forgetting the trivial inequalities, x and y are both greater than or equal to 0. Now this problem has an objective function of 10x plus 9y. And we know that the optimum solution to this problem is at one of these 5 vertices surrounding the feasible region. So the first thing we need to do is to convert the problem to its augmented form by introducing slack variables. So here we will need 3 slack variables, S1, S2 and S3, since we have 3 constraints. So our inequalities become x plus y plus S1 equals 12, 2x plus 3y plus S2 equals 30, and 2x plus y plus S3 equals 20. And not forgetting the trivial inequalities that need to be added, S1 is greater than or equal to 0, S2 is greater than or equal to 0, and S3 is greater than or equal to 0. So next we need to rewrite the objective function. So the objective function becomes p minus 10x minus 9y equals 0. So we now have 4 equations, but no unique solution. So we know that the solution is one of these 5 vertices, and we know that at the origin x equals 0 and y equals 0, we know at this vertex here, since it is the intersection of the line y equals 0 and the line 2x plus y equals 20, that y must be equal to 0 and S3 must be equal to 0 at this point. And likewise, this is the intersection of the line 2x plus y equals 20 and the line x plus y equals 12. So at this point, we know that S3 equals 0 and S1 equals 0. So each vertex is defined by the intersection of 2 lines where the associated variables equal 0. And the simplex tableau effectively sets out these equations ready to solve them in pairs at each iteration. So here we have an initial tableau. It's important to note that the objective function is always seen at the bottom of the table. So since we have negative 10x, negative 10 goes in the x column, and we have negative 9y, minus 9 must go in the y column. We have no slack variables, so these all become 0, and the right hand side is 0. So then we add each constraint in turn to the table. So we're going to start with the first one. So we have 1x plus 1y plus 1s1 and no s2 or s3, and this is equal to 12. So that's our first row. Then our second constraint is 2x plus 3y with no s1 plus 1s2, no s3, and that is equal to 30. And then our third constraint refers to the row 2x's plus 1y, no s1, no s2, and 1s3, and that is equal to 20. So we're going to look at the basic variable column now, and the basic variables are those that are non-zero at any stage. So since the method starts at the origin, then x must equal 0, and so must y at the beginning. So the non-zero basic variable for the first constraint, since x and y both equal 0, must be s1, For the second constraint, it must be S2. For the third constraint, S3. And for the objective function, this must be P. So we need to make sure you leave some space on the right hand side of this table here in order to do some calculations when we do our iterations. So here's a table that we filled in earlier, and it's just important to note that common mistakes are leaving out the objective function or forgetting that it must be on the bottom row. So this is often called the objective row. And another common mistake is not aligning the columns up correctly. Okay, so in our next session we're going to look at performing iterations.